Good morning, everyone. My name is Muskan, and I'll be presenting a practical demonstration for my subject, Financial Analysis and Modeling. So, in this video, I'll be showing how to build a loan amortization schedule in Excel. So, as we all know, a loan amortization schedule is a table that shows how every EMI payment is divided between interest and principal repayment. So it also, this concept is very useful in banking, corporate finance, and personal finance as well. So we are starting with loan amortization. So before we start building the model, let's quickly understand the concept. So when we take a loan, we agree to pay back the amount with interest in equal monthly installments, which is known as the EMI. Each EMI contains two parts. One part goes to pay the interest on the outstanding loan, and the other part goes to reduce the principal amount. Over the time, as the loan balance goes down, the interest portion becomes smaller and the principal portion becomes larger. This gradual repayment process is popularly known as amortization. So now let's start building the model. And first we'll enter the input data. These are the assumptions that we will be taking for the loan amortization. So starting with the first thing, that is the parameter. Then we have the value that we are going to put. Then we have, so in the parameter, we'll so after entering the value of the parameter, first we'll have the loan amount, which we are taking as 5 lakhs. Then we have the annual interest rate, which we are which we have taken as 10%. Then moving on to the third one is the loan tenure, which will be approximately 3 years. Then we'll have payment per year, which is 12 months, which is 12 monthly payment. Then we have total period, which will be we are calculating the total period, which will be equals to B3 uh, C5 equals to C5 into C6. Yeah. So total period will be loan tenure into payment per year. So we are assuming a loan of 5 lakhs at an annual interest rate of 10%, which is to be repaid over 3 years in monthly installment. So the total number of periods that is being calculated by multiplying 3 years, which is the loan tenure, with payment per year of 12 months, which is on monthly payment, it gives 36 payments. Now we are moving on to step 2. Next, we'll calculate the EMI using Excel's PMT function. So the PMT function calculates the fixed payment for a loan based on constant interest and equal installments. So we'll have equals to, we'll search for the function PMT, bracket open. So we have 10%, rate is 10% divided, payment per year is 12, comma, 36, which is the total period, comma, it's the minus 5 lakh, which is the loan amount. We close the bracket. So we get 16,133.59. So here, when we press enter, this is this 16,133.59, which we round off to 16,134. This means this is the EMI that we get. So this means we'll pay 16,133.59 every month for 36 months. So here we can write EMI. EMI. Okay. We'll highlight this cell. Now we will build the month by month amortization table or the schedule to see how each EMI is split into interest and principal. So we create a new sheet. So the next step that we are doing is to create an amortization table. So we are starting with A11. So in row 11, we are creating table with payment number, then we'll have is beginning balance, EMI, then we have is interest, principal, and then is the ending balance. So starting with next, we will prepare the amortization table to show how each EMI is split between interest and principal and how the outstanding balance decreases every month. This is payment number one. So, then beginning balance will be 5 lakhs. So payment number is 1. Beginning balance is the loan amount. EMI is fixed at 16,133.59, which we just calculated. So EMI will be fixed for all the years. So interest is calculated as beginning balance into monthly interest rate. So we'll have equals to beginning balance into monthly interest rate. Principal is EMI minus interest. And ending balance is beginning balance minus principal. So payment number is from 1 to 36 months, as it will be paid in 36 equal installments. So first is beginning balance, which is 5 lakhs, which is the loan amount. Then we have EMI, which is we have already calculated as 16,133.59. Under interest, we have so under interest, first is EMI is already we have calculated. Interest table, which is D12, we'll have equals to B12 into bracket open C4 divided C6 bracket close. Then moving on to the principal, we'll have equals to C12 minus D12. Enter. Ending balance will be equals to B12 minus E12. This is beginning minus principal. Principal is C12, which is EMI minus D12, which is interest. So principal is EMI minus interest. These are the formulas. For the second payment here, which is row 13, payment number 2, this balance, which is F12, becomes the beginning balance now. So equals to F12. This has become the beginning balance now. EMI is same here, and EMI will be same throughout 36 months. EMI remains constant. Now, under interest, we have B13, which is this balancing beginning balance. So we'll have equals to bracket open B13, which is the beginning balance, we have the opening bracket C4 divided by C6, closing brackets, equals to into equals to. Here we have equals to EMI minus interest. For ending balance, we have equals to beginning balance minus principal. Now this becomes, for third payment number, the beginning balance will become the ending balance of the second payment number. Enter. As we all know, EMI will always remain the same. Interest is beginning balance. It's right here is beginning balance into C4 divided by C6. This is the formula for interest. So here we have the beginning balance as equals to beginning balance is this into bracket open C4 divided by C6. Principal is equals to EMI minus interest. Ending balance is equals to beginning minus principal. Similarly, we move on. EMI will always remain constant. So this is the EMI which always will remain constant. So I think I can drag it down to, it is not going to come. So it is always equals to EMI. equals to EMI. Here the interest is beginning balance equals to beginning balance into C4 divided by C6. Principal is EMI minus interest equals to EMI minus interest. Ending balance is equals to beginning balance minus principal equals to beginning balance equals to EMI is 16,133.59 minus interest is 3762.76 equals to. Okay, so now we have this as equals to this. Interest is beginning balance equals to beginning balance into C4 this C4 C6. Principal will be equals to EMI minus interest. Equals to goes. Interest is beginning amount into equals to, here we have equals to the beginning amount into principal is equals to EMI minus interest. Interest here will be beginning amount will be equals to beginning amount into this will become principal will be equals to EMI minus interest. Interest is equals to beginning amount into C4 divided by C6, bracket close. Principal will be equals to EMI minus interest. Close to. Similarly, we have to do it for 36 months. Equals to beginning amount into bracket open C4, which is 10% divided by C6, which is 12 monthly payments, bracket close. Principal will be equals to EMI minus interest. So similarly, we will have to do it for 36 months. So we have calculated this for 36 months approximately. And now the total principal paid and the total interest paid total payments, which is principal plus interest so here we have total principal paid is our 5 lakhs. Next. Total interest paid that has come is 8809.42 and so the total payment comes up to 580 comes up to equals to this plus this 809.42. Yes. So this was the complete demonstration of creating a loan amortization schedule in Excel. So we started with inputs, calculated the EMI using the PMT function, then built the month-wise breakup of payments and visualized it through a chart. So this kind of model is very useful for banks, finance, students, as well as for corporate professionals to analyze repayment schedule and the cost of borrowing. In the next part of the video, I'll also show you another financial modeling. So for this part, thank you very much.